Hello, my wonderful students. This is, let me zoom out a little bit. This is foldable number 5, and we're doing section 2.4 transformations. These are the translations of the transformations of f of x is equal to the square root of x. This is a square root function. So we're going to zoom in here. So I didn't draw the parent graph of this one because I always like to do the first one with you guys. And, zoom a little out. Right there, perfect. So if you see, this is a vertical translation up, but we're going to go ahead and graph our parent function. So we have y is equal to, or f of x is equal to the square root of x, or y is equal to square root of x. So if we have x is 0, we plug that in here and we get 0. So our first point is here. When we plug in square root of 1, we get 1. So 1, 1. We plug in x for 4, 1, 2, 3, 4, and we get the square root of 4 is 2. So 4 and 2. We get 9, which is the last point here, and we take the square root of that, and we get 3. That's about there. And we have 16, but if we were to go all the way to 16, that would be way out here, far away, and it won't fit in our graph. So we're going to go ahead and graph this. So our parent function for square root of x looks like this. So now for this one, we're going to go ahead and do a vertical translation up. So in order to do that, we're going to add 1 to each of these y variables, because it's just the f of x function, which is here, plus 1. So we have 0 plus 1 is 1. So at 0, 1. 1 plus 1 is 2. So at 1, 2. 2 plus 1 is 3. So at at 4, 3. This is a 9, so at 3 plus 1 is 4, so at 9, 4. And you can see here that this translated up 1 unit. If we go from each dot, we go up 1, up 1, up 1, and up 1. The next one here is a vertical translation downwards. So switch colors. And we have our parent graph already. Let's go ahead and label these right now. So this is our parent graph. This was our parent up here too. Okay. And we'll do the other ones later. So we'll go back to our blue. This one here is the f of x minus 2. So we just had our f of x was equal to x squared, or sorry, square root of x. And this ends up being the result for our parent function. So what we're going to do is we're going to be subtracting 2 from this function in order to get these numbers here. So in order to do that, we're just going to get 0 minus 2 gives us a negative 2. So at 0, negative 2. Then we're going to get 1 minus 2 gives a negative 1. So at 1, negative 1. Then we're going to get 4, which ended up being 2 minus 2 gives us a 0. So at 2, that's going to be at 4, 0, because our x is still 4. I got a little confused because of this. Our x is still 4. Now our new x is 9, which is over here. And our square root of 9 was 3, so 3 minus 2 was 1. So at 9, 1. And our 16, which is way out there, is going to be our square root of 16 is 4. 4 minus 2 is 2. But we're not going to plot the point because it would be like way out here, and we're going to cut this out anyways on this dotted line, so we won't even get that anyways. But we're going to go ahead and graph what we have, which is this. And you see that there. And some of you might ask, why can't we go this way? And we didn't go this way either on this one. And this is the biggest reason why, because I'll do it up here even though we're going to be able to, we have to cut it out. But if you have the square root, what happens when you put a negative in our square root? We get an imaginary number. And we're not really trying to deal with imaginary numbers right now. We're just worrying about all the real numbers that we're using. So we're not going to be going this way because it's going to give us kind of like a wonky answer, because you can't really take the square root of a negative. That's why we end up getting an imaginary number. And I know it's review, but I just wanted to make sure you guys understood. That's why we're only graphing to the right side of the y-axis here. Y-axis here. It's because that we don't want to take the square root of a negative number to get an imaginary number.